Let's go. As usual, waiting for Twitch to catch up. There we go. I should be live. Hello everyone, welcome back to the Advent of Code, and possibly some more work on the compiler if today proves to be easy. We'll see how that goes. We only have one day to go through today, because I've done 1, 2, 3 yesterday, so we only have day 4 to go through. So yeah, let's get started. So I've also done something, if that's of interest. I've redone day 1, but entirely at the type level, which means the solution is computed at compilation time, which was fun. So that's on the repo if you want to have a look. But today, we're going to be breaking back the 2D maps. We have, yet again, a 2D problem. I read through very quickly. It's purely... I've been kind of tempted to see if I wanted to do a kind of Comonad situation for the solution, because this is clearly like some kind of cellular automaton. What I'm worried about is like part 1 is trivially doable by just doing lookups. I don't know how that's gonna work for part 2, because I don't know what part 2 is going to be yet. So let's do the setup. Let's do the part 1 in the naive way, and we'll see how that brings us into part 2. And just to have a quick look, how big is the input? It's pretty big. Okay. Last thing to do will be to copy the example. So that we can try our code with... Okay, so it's just the amount of places that have fewer than 4 rolls of paper. Okay. So our example is going to be this. Okay. So here I'm going to cheat a tiny bit. Well, first I'm going to do the input. Well, no, let me cheat a tiny bit. In the sense that I have a bunch of functions and types and things, like a small library of code that I've been like copying from year to year and developing from year to year. It includes a grid thing that like contains a flat vector of values and coordinates, which means I can just create something from a 2D list, and that I will get a grid on which I can do like direct lookups, basically. And it also has a few functions, such as like the 8 surrounding points in a grid that filters to only keep the points that are in bounds, which, you know, is... The function grid 8 surrounding points is kind of horrible in terms of naming, but it makes a problem like today's pretty straightforward. So let's import AOC, and I need a grid flat as well. So our input is going to be a grid of Boolean, I suppose? Like, how do we represent the state of this? I could use a custom type, but I think Boolean is perfectly good enough. So parsing the input is going to be transforming a string, like this one, into a grid. Our grid type already has a function which is from 2D list, so from a list of lists. So if I transform our string into a list of string, which will be a list of character, and then we just map something onto it, we will get what we need. So this will be a from 2D list of map read character. of lines. The reason I'm doing the map, this double map here, instead of doing only one before doing the lines, is I don't want to have to transform a new line character into a boolean. That would make no sense. And here, read character is as basic as saying that is a character. Actually, I'm not even gonna try to make a function for this. This is equal this. So we'll get true when we have this, and we'll get false when we have literally anything else. Let's just try this on its own, actually. Do I have... I don't have a show function on this, but I have a display with, I think, if I remember correctly. Okay, so given the function that given a point, a value in my grid returns a string, will give a string for the whole grid. Oh, that's... I can tell that this code is old by the fact that by the way this is indented. I no longer indent code this way. Nowadays, I would write all of this with a like do block in the list monad, and I would have a lot less indentation. It's fun to see see the difference in terms of style. So to try this, let's try putting a string, which is going to be a display with, and I'll give a function here, of the test input, which will be the result of parsing this thing, to check that parsing this thing works correctly. And this is going to be a function that will ignore the position, and will only get the Boolean value, and will return if b, then this, else this. Let's try to compile that and run it. And this is day 4. Oh, I didn't remove those things. Let me do that quickly. When I was doing earlier today the type level thing for day 1, I was tempted to add some actual type level stuff library inside my Advent of Code library. But that's not something I actually want to keep. So let's remove that and let's continue without it. Okay. Yes, I have a bunch of those errors, that's fine. Okay, so this is what we print after parsing. So we parse the input and then we print it back. And that seems consistent to me. Perfect. Okay. So part 1 is going to be about counting. So we have already a function, which is, I think, all points. There we go. So this is going to... So we have a function that, given a grid, like we have, gives us the list of all the points within the grid. So this thing is going to be some kind of count true. We're going to go through a list of things and count the number of times where something is true. And this is going to be for a point P in all the points of the grid. I abbreviate to G. So for every point P in all of the points of G, we need to have a look at some value n, which will be the sum, well, the count true of a new list, which is going to be for each neighbor in the grid 8 surrounding points, which again is this function here that, given some grid and a point, gives me the 8 surrounding points and filters to only keep the ones that are in bounds. So it's going to be for this grid at this point. And that gives me, actually, maybe I don't want to use that, because that gives me points. I think I want the grid 8 neighbors, which gives me the actual values. So I guess it is just a count true of the grid 8 neighbors, in this grid of this point. So that tells me how many surrounding things are true. And I will count this cell as true as far as the result is concerned. If, what is the thing we're trying to do again? Can only access if there are fewer than 4 rolls of paper. So fewer than 4 being strictly fewer, I suppose. It doesn't say. But I suppose it's strictly less than 4, and if it's not, we'll see the error very quickly. Anyway. So this would be n is less than 4. Okay. I'm going to remove this print here. That is indeed incorrect. Now n is not something that we iterate over. This is just a number. So we get 19 for the test input there. And that is incorrect. Oh, but this doesn't seem to be... Wait, I don't understand something. Oh, of course, I don't want to do this for all points. I want to do this... I want to do this for only the points that do have a thing. Okay. So that means I need to remove the points at which there is... So I need to guard to only keep the values for which the value in the grid at this point is true, meaning there is a roll of paper. That gives us 13. Is that correct? 13. So that should be correct. Let's try this value for our real input to see if this works. Okay, that worked. And now let's see if this naive solution will be good enough for part 2. Aha, so this is an iterating process. Okay. Stop once no more rolls of paper are accessible by a forklift. Okay. I am worried about the performance consideration, but otherwise, from a code perspective, this is fairly straightforward. The only thing is, I don't think I have any kind of, like, map function on this thing. So maybe I'll need to do... I do have mapping. Perfect. And do I have equality on the thing? I do have equality on the thing. So I can write this in a very naive way, and we will see if it works or not. So the very naive way will be if we introduce a function which is remove accessible roles that takes our input, which is a grid, and returns a new version of the input in which we have removed all of those roles. This is going to be very similar to this. This is going to be given some grid. We're going to do this pmap function there, this one, that will do an update with that applies this function on all points. So this is going to be, and I can remove, actually, no, I will need to have it in scope. Okay, so this is going to be a flip pmap of, given a point P and a value B, which tells us whether that thing can be removed, we will decide what the new Boolean value is. And that Boolean value will be true only if. So it's going to be true if it was already true. It will never become true, or if it was false before. So it has to be true in the first place, and the count true of the grid 8 neighbors of that point in the grid is greater or equal to 4. Because if that is true, there are more than 4 rolls of paper in the surrounding 8, then it remains true. Otherwise, it becomes false. And if it was already false, it remains false because the end just short circuits anyway. So I think that's enough to. So here I need to give the grid as well. Okay, so that should be enough to remove the accessible rolls. Oh, but I need to count them. I need to count. That being said, I don't even really need to count them. I could count. Yeah, I could do that the ugly way, let's be honest. So if I have my input here and I do a go input here, yeah, let's do this a naive way and let's see if the performance is an issue or not. So the naive way will be that. Wait, so I want to return how many rolls have been removed. So this is going to be how many rolls there are at first minus how many rolls there are at the end. So this is going to be count true. So I'm going to introduce another function for readability, count rolls, given some our input gives us an int, and count rolls is simply going to be a count true of transforming this thing into a list, which is toList. Which might conflict with the existing toList. We'll see if I have to. I might add an as G here for grid. That way I can say G toList if there is. That way that avoids the conflict. So our part 2 is going to be counting the rolls in the input minus counting the rolls after doing as many substitutions as possible using a go function. And where go is going to be for a given grid G, let G prime equals remove accessible rolls of G in if G different from G prime, then go G prime, else G. Well, yeah. That's extremely naive, and that feels very inefficient. We are checking to see, have we actually, like, we're just doing a difference on the entire grid at every step. This feels extremely inefficient, but we'll see if it's actually, like, inefficient to the point of being a problem, or if it just terminates anyway immediately, and therefore we don't really care. It terminates almost immediately, therefore we don't really care about it being bad, if it is correct. We get 43 for the test input, which is what we get here. So we hope that this thing is correct for the actual input. And it was. Okay, well, the naive solution was good enough. I've cheated a tiny bit in the sense that, like, I've been using this already existing type, but from a performance perspective, there are, of course, the ways we can improve this would be, rather than counting the number of rolls by counting the number of characters that are true in our gigantic grid and doing like this minus thing that is kind of horrible, we could change this function to keep track of how many things have been removed, basically rewriting this to keep track of how many things have been removed, and keep a tally of that as we go, and use that tally to be like, oh, this iteration removed 0, therefore we have to stop. But this is good enough in terms of performance. Like, it's not fast, but it's fast enough. So I think I'm okay with this. I'm trying to think if there's something else interesting we can do with this. Like, is there some interesting kind of approach? Again, common add could be interesting, but the performance would probably not be great either. I don't know. I'll think about it, and if I have ideas, I will revisit it in other days. For now, I think this is gonna be it for day 4. So let me commit this, and then we can move back to our compiler project. Could I do this one at the type level? I don't think so. Oh, I mean, technically it's possible, but can I easily do it at the type level? I don't think so. Or at least not right now. I would need to think about it. Okay, well, that concludes day 4. We are at the 21-minute mark. Okay,